The p-value is probably the most misunderstood number in statistics. In this video, I'll show you where it comes from, how to calculate it, and how to use it correctly in hypothesis testing. It is very important that you have watched the previous video on hypothesis tests, as there will be a lot of references, and that video will make this video a lot easier to understand. Now, what is a p-value in terms of a hypothesis test? Well, with the hypothesis test, we were given the extreme values. For a one-tailed test, we have 1, and for a two-tailed test, we get 2. The p-value is the decimal value that is next to the z value that will then give you an extreme value, which is your observed mean. So if we take our original equation, the observed mean equals the null hypothesis mean plus or minus z times standard deviation divided by the root of m. Now rearrange this to get z. This shall result in z equals observed mean minus the null hypothesis mean, all divided by standard deviation over root m. It is very important to remember this equation as it is used a lot and is called the hypothesis test statistic. Fun fact, this number is how many standard errors are observed from the mean away from the claimed value. This z is called our z-score. If we are in a two-tailed test, take the magnitude and times by -1, or in other words, switch the score to negative if it isn't already. Now that we have this, we can use what's called a cumulative distribution function to get our p-value. Simply substitute that in or look it up and we get our p-value. Great, so now we have our p-value, there are a few things to go over. First of all, if we're using a two-tailed test, remember to double the p-value. Leave it the same if on a one-tailed test, and if we are doing a greater than hypothesis test, the p-value will be 1 minus p, and the lesser than test will stay the same. And as I said earlier, make sure two-tailed test, the p-value is doubled. Now that is how to work out the p-value, but what does this mean? Well, a p-value doesn't tell you whether a hypothesis is true. This is a common mistake. It actually tells you how surprising your data would be if the null hypothesis was true. So, if I had a p-value of 0.03 for example, then if I assume the null hypothesis is true, there's about a 3% chance of observing data this extreme or more extreme. We can also use the p-value to conclude a hypothesis test. We can compare the p-value with our chosen significance level, usually 5%. For example, if the p-value is smaller than the significance level, we reject the null hypothesis, otherwise we do not reject it. Then that is it for this video. If you found this video helpful, please like this video and subscribe to support the channel, and I hope to see you in another video.